Today I'm going to talk you through the star life cycle diagram. On here we have all of the types of star that you could be asked about as a GCSE student. I'm going to talk you through as well the changes that go on between the different life cycles of the star. So here we go. All stars start out as some sort of nebula. Nebulas are giant gas clouds, and you need to remember that they are pulled together by gravity. So gravity pulls on everything in the universe, and it causes these clouds to condense. And as they condense, they start to spin, the materials within them collide, and they become a protostar. They start to glow in the middle, and eventually they get so hot that they start to fuse elements together. So in a main sequence, we get fusion. And stars that are doing fusion release large amounts of energy outwards. So if we were to draw a diagram, for example, of a star, we would see gravity pulling inwards. I'm not doing a very good job of my arrows this evening. And at the same time, we'd have outwards a balancing force. So the forces in a main sequence are balanced. And that's in a main sequence here. Okay. Now, our sun is a main sequence star, and I'm going to write it over on this side, okay, for a reason. So after a star has been a nebula, it's become a protostar, it's become a main sequence. When it runs out of fuel, it can no longer fuse hydrogen to make helium. So down one of these two routes. Now, our sun is a relatively small star, so it will become a red giant next, and it will swell, and its surface will cool as well, giving it a red colour rather than a white colour. So it will swell and it will cool. Now, eventually it will run out of fusible nuclei completely, so it will run out of hydrogen, and it will become a white dwarf. So I would say really that fusion stops, and that means that it will shrink. Okay, so it shrinks to become a dwarf, but interestingly, it's white again, so it must heat up. And then there's no more fusion in a white dwarf, so it cools to become a red dwarf. And eventually it cools even further to become a black dwarf. And black dwarfs are invisible because they're not giving off any radiation at all. Okay. Now down this side, something more exciting happens. So these are high mass stars. And high mass in terms of maybe 100 or 200 times the size of our sun. So our sun, remember, is coming down this side. The exam board would love to ask you questions about that. But down this side, we've got high mass stars. And they do the same. So they swell and they cool, but they swell up to make a supergiant. Okay, so the big stars become bigger giants, supergiants. And when they run out of fusible material, when they run out of fuel, they do something really exciting. They do the supernova, and a supernova is this incredibly massive explosion, this huge sort of shattering of everything that is the star. And they throw out huge quantities of material. In this particular moment, we get the fusion of heavy elements to produce super stuff like uranium, gold, other very large nuclei, okay? So supernova is this giant explosion at the end of a red supergiant's life. The supernova leaves behind either a black hole or a neutron star. So supernovae leave behind neutron stars, and really big, so these were really big supernovae leave behind black holes. And black holes are a little bit weird because, and neutron stars to the same extent, they have really high gravity. And that's so much, they're so heavy that light can't escape. So we can't see black holes or neutron stars. I hope that was useful for you today. Hopefully I'll get better at them with practice. If there's any topic you would like me to cover in particular, if you could comment underneath this video, I'll try and make you some new videos in the next week or so. Thanks, bye.